Hello, everyone, and welcome to a special edition of the Broadband Universe podcast series. This is the third in our series of three conversations with members of the Hexatronic U.S. team as we explore multiple aspects of microcabling systems. I'm Craig Corbin, and it is a pleasure to welcome my guest today, Roger Vaughn, the Vice President of Engineering for Hexatronic U.S. Roger, welcome to the Broadband Universe.
Thank you. I appreciate being here.
Absolutely. We have had a blast talking with Benny and Brad, and can't wait to have our conversation today. And, you know, when we look at your background in the world of fiber optics, a lot of experience, and I'd love to sort of set the scene because, you know, part of that curriculum vitae includes a number of patents.
Yes.
Give us a little bit of your background, if you would.
Yeah, so started out in the industry way back in '94, so about 29 years of experience, and you know, along with that, you get a lot of engineering, and some of those lead to patents, and those patents I'm pretty proud of. I've got cabling patents, I've got patents with connectivity, I've got patents on design, lot of engineering, a lot of fun working with others, getting those projects completed, and receiving revenue and other things from those projects. It's a great time, great experience, and great career.
Well, hats off to you on that, and also as a native of the Tar Heel State, it is great to know that you got your engineering degree at NC State there in Raleigh. Spent many years in the state's capital, and a lot of great memories there. But you know, obviously, our topic today, sort of wrapping up that conversation. We started talking with Benny about the value of microcabling systems versus traditional. Then in Brad, a use case, if you will,
Yes.
of delivering the most reliable, scalable, and cost-effective. And today's conversation, quite honestly, I'm looking forward to so much because it is very timely, and that is microduct blown fiber cabling for MDUs. And
Yes.
as anyone knows, of course, I'm now in the metro Atlanta, the explosion of apartment complexes, condos everywhere.
Yes.
MDUs are such a huge part of the conversation, and obviously, you know, there is a tremendous savings when we talk about either new construct or retrofitting
Yes.
by using microduct blown cable systems versus the traditional fiber optic cabling. Let's talk about, you know, sort of an idea of where this all started and how your involvement from Hexatronic is playing a role.
Sure. So one of the key features of air-blown fiber solutions is being able to transport or you know, blow the fiber a long distance. So we can blow it between a 2 or 24 fiber unit up to a kilometer away. And by doing that, we can really simplify the whole process of placing fiber into an MDU. And really, an MDU is just a consolidation of single-family homes. So if you think of a regular neighborhood and you've got lot lines, if you shrink those lot lines down to, say, 20 or 35 feet, now each house is next to each other, and now we just stack them on top of each other. It's really nothing different than a really condensed neighborhood. And so the concept with air-blown fiber is just to address those individual units as a house, per se. And in doing so, we have an individual duct or fiber that is going to be provisioned for each one of those units. And we run that all the way back to your fiber distribution hub. A lot of times in splice and place systems, more traditional methods, for whatever reason, there's a terminal placed on the side of the building. Well, that's not necessary. That just leads to different connectivity that's added to the whole process. And in doing so, you're adding labor, you're adding time, and it slows down the entire build. So by using an air-blown fiber solution and that ability to blow the fiber a long distance, we can position a fiber distribution hub centrally in between multiple buildings and blow that tremendously long distance within 5 to 10 minutes. It really doesn't take long at all. It seems like a long distance, But with our capability with the air-blown fiber gun, the blowing equipment that we have in the fiber unit, very quick, very easy. So
Let's talk about that. Let's talk
yeah,
about that, because when we review the micro cable technology and process, pushing with air assistance versus pulling conventional fiber, walk us through the overview of the concept itself.
yeah. So the concept's been around for several decades now. If you look to European area, it's traditional. That's how they install cable. That's how they install fiber units. It's nothing unusual, right? So in the ability to push a fiber versus pull a fiber, you're actually putting much less stress on the fiber or the cable itself. The air is there just to keep the friction down. So you're really not pulling the fiber with the air or pushing it with the air. Is simply in there to levitate and allow the cable to stay off the walls and minimize the amount of friction. So the unit itself has two little wheels, and it's pushing the fiber basically into a frictionless environment. So if you can imagine you're pushing the cable and there's no resistance, well, you can push it a long distance. And that's the advantage of the air-blown fiber solution. We can rapidly deploy. We can deploy with a very well-known technology, and we can deploy in such a way that we're not going to damage anything. Also, because that is such a unique environment that we're placing it into, we don't have to have as strong a cable. We don't have to have all the components that traditional cables need to survive that installation process. And that's really all you're doing when you're making a cable, is you're making a cable to survive installation. Once it's there, it doesn't need all that protection. It doesn't need all that strength. It just sits there. So by removing all those components, we reduce the cost of the cable. We shrink down the size. We're able to install it without any fear of damaging the cable, and we are able to install it quite quickly. So there's lots of advantages to air-blown fiber solutions across the board.
Roger, something that you mentioned in that last remark, I think, is key. And you talked about reducing the stress on
Yep.
the cable, and the fact that the traditional design is such that it's to survive installation. But obviously, this would, at least from my perspective, allow for a longer lifespan, if you will,
Yes.
for that cable, knowing that you're not stressing it to start with.
Yep.
I'm curious, from the standpoint, you also mentioned the environment, the duct.
Yes.
Talk about the differences in microducts when we are installing these systems.
Yeah, so when you look at the smaller cables, smaller fiber units that we're using, you don't need as large a space. And in fact, for air-blown fiber solutions, we want to have a little smaller space, a little more confined area, because we're pushing it and we want to float it on air. We don't want a large cavity to push this cable through.
Right.
So when you look at traditional duct, it can be 1.25 inches, 1.5 inches, 2 inches are pretty common. But the cables that are going in there are maybe 25% of the size. That's really not optimal. You're putting something very small in a large space, and you're taking up a lot of space in a trench or in a right-of-way area that's not necessary. So if we look at like a 2-inch conduit, that's maybe one large cable, maybe 1152 cable, 864, something like that in there, with our micro cabling technology and the micro duct, we put in a 4-way or maybe even a 7-way in that same space. Now we have capacity for 4 pathways, future pathways. We can branch off from that location very easily, so we can different pathways within that structure. So it's very adaptable, very easy to use, and it's also environmentally friendly. We're only putting in, we're putting in multiple pathways. We're not having to go back in, retrench, rebore. We're not having to re-sleeve that 2-inch to put an additional cable in. So we're putting really less material in overall when you look at comparison of one to one with the traditional systems.
Which makes a difference on the bottom line. And also,
Absolutely.
one of the terms that you just mentioned, the flexibility, the capability of being able to build to the immediate demand, and then yet have the flexibility to be prepared for future growth.
Absolutely.
And
Yes.
being able to grow with that. That's an intriguing concept, and one that I know isn't necessarily top of mind for a lot of folks in the industry, but given the immense growth that we are on the cusp of, with all the BEAD funding and the other programs coming the next 5-10 years, are going to be just off the charts with projects. Knowing that you're having the ability to decrease the amount of product that you're putting in right up front is a huge impact on that bottom
Yes.
line. I'm curious from your perspective, the impact not only from that, but also how that affects the length of time that it takes to complete a project. I would assume, in theory, that helps speed up the process typically.
Absolutely, absolutely. So when you're doing an installation, digging a trench is digging a trench, or a horizontal directional drill is the same. That we can't get away from, and it's a large cost of the installation. What we're saying is maximize what you're putting in the ground. There's no sense in putting a single solution when you can have a multi-pass solution, right? So it just makes sense. It's hard for us, actually, when you look at the technology, to understand why you would go with an older system that limits your ability, limits your future flexibility, limits your current flexibility. As I mentioned, with multiple pathways, they don't all have to end up at the same place. We can go halfway down and take a left and go into a new development, or reach a new city, whatever we need to do. We don't have to follow that single path or cut into that path and have now another handhole and another splice closure. We can just continue on with a single cable to wherever we need to go. So it's really a fascinating technology. Like I said, I've been in the industry 29 years, did it traditional for many of those years.
Right.
And when you look at the air-blown fiber solution, it just makes sense. It's just that simple to understand.
That is exciting. Well, we've talked about getting the fiber into the duct. Let's talk about termination.
Yes.
We have to distribute that. Get your hubs,
Yep.
the terminal box, and then talk us through how that all works together.
Yeah, so connectivity is relatively the same. So there's no real new devices or new technology that have to deal with at the connectivity side. The great thing about it is now we've got a smaller cable, a smaller bend radius. It's easier to prep, easier to access. It's you can store more slack into a handhole. There's just every time you look at the system, every time you approach and say, well, maybe this is a downside, it's actually an advantage. There's really very little instances I can look at and say, this is either the same or it's better. There's no real downside that I've found, and it just makes sense. Let's evolve our technologies. Let's evolve our methods of doing construction, and go with the best practices. And this really is one of the best practices out there. It's really a neat technology, and something that we've adopted. And for the rest of my career, I think this is where we're headed.
That is exciting. When we talk about greenfield opportunities, new builds all over the place. Here in the metro, it seems that every week I will see a new development going up and in it. If I'm a developer and I'm evaluating the best way to serve a new build situation, what would be the typical time frame that you would begin the process? You make your decision that this is the way that you're going to go, to have that become reality in parallel with the construction process. Talk about that, if you would.
Yeah, so let's look at a new customer, the way we approach a new customer.
Yeah.
So if they've done it, done traditional systems before, and they're a little skeptical, we'll approach that customer. We'll say, let's take a look at your design, and we're going to approach and do an overlay with an air-blown fiber or a microduct solution for you, and you'll see the differences, and you'll see the amount of material that's going into that development is less. And when you look at some of the aspects of a development, you don't want to see pedestals in the front yard. You don't want to see handholds. And our solution, the microduct solution, eliminates a lot of that connectivity that's not necessary. Again, we can blow up to a kilometer away, so we don't have to have a connectivity point in the front yard. We don't have to have or other connectivity points where we're branching off in the neighborhood. We simply blow from one point to the next, from the house to the FDH, and that's it. So eliminating all those components not only saves money, it also saves time, and it's going to save roughly around 25 to 30% on that initial construction cost. So when you start talking numbers like that, that's a big item to convince a developer this is a better technology, it's much easier to install, and it's going to look better in your neighborhood.
That is substantial. And the key that I always come back to is the ability to come back in down the line and add to or expand
Yes.
the footprint very easily. I'm also curious, having spent a number of years with not only new build MDU situations, but those existing complexes that would want to retrofit,
Yes.
replace the old legacy infrastructure with new. How does microduct and air-blown fiber work in those situations?
Yeah, so a lot of times older MDUs are approached with microduct, whether it's the type of microduct we're using or other traditional, and then cables pulled into that. So with air-blown fiber, again, we're going a longer distance. It's going to be a smaller duct. If you look at relative size that typical brownfield MDUs are installed with, it's about a half-inch duct. Ours is about quarter-inch.
Right.
Significant difference. Again, less material, less issues with space constraints, and being able to route that. It's much more flexible with a smaller unit. You can route that into walls. You can route that to the fiber terminal, wherever the media center might be. It's just an overall easier process to get to that point. When you look at the aspect of again, the aesthetics within the complex, getting to the unit, we're not going to have that terminal on the side of the building, so we don't have to locate another telco closet or use a mop closet or a laundry room or stairwell to occupy with other connectivity. You're simply going to have a pathway going up, routing over to the units, and then we're blowing a fiber within that directly to the unit. It's really simplifies the whole process.
It becomes transformative in so many different ways. And you talk about, something as straightforward as the aesthetics, but that is very much a part from the owner's standpoint. They're marketing the ability to have a good-looking property in a competitive situation. So we've talked about the ease of use, the flexibility. Let's look at a comparison, say in an MDU complex, the cost per unit comparing the traditional legacy installations versus the air-blown fiber. What does that look like?
Yeah, so when we look at a development, we look at it, as I mentioned, similar to a neighborhood. We've just condensed it down. And one of the architectures within the air-blown fiber solution is called a regionalized FDH, regionalized fiber distribution hub. So we put it a little closer versus a centralized concept. So centralized, you might be hitting 288 units out of that centralized. We'll break that down to around 96. And in doing so, we're closer to the actual user, so we don't have as much material that's spreading out, right? So if we have a centralized, we've got to bring everything back to that centralized location. If we regionalize it, we're bringing everything back to a closer FDH. Again, it doesn't have to be that close because we can blow up to a kilometer. But again, the amount of material that's being used is reduced. The speed to installation is being increased. The amount of material being placed is less. It's hard for me to understand why many would go to a traditional system when you start looking at every aspect of an air-blown fiber solution, and it's just so simple and makes sense on every aspect of a build. It's that easy to understand. And many of our customers, when they look at the system, they have many doubts and they have to try to shoot holes in in what's been designed, and it's hard for them to see that this actually does work. And why haven't we seen this before? Why isn't this something that's been used? It has. It's been used for over almost 3 decades in Europe now. So it's very well established, very easy to understand, and I look forward to deploying many MDUs here in the future. I see that happening very soon, and we're doing it right now.
It has to be exciting and rewarding, both personally and professionally, when you
Yes.
look at the impact that this technology, this approach, is making on the industry in so many different ways. And today our discussion limited predominantly to MDUs, but that is such a big part of the world of broadband now, because the sheer population explosion is creating a resulting increase in MDU expansion, and knowing that this is going to be an opportunity to do more for less with greater flexibility for the future, just has to be something that you view extremely positively. Talk about them. I'll ask you to, as we wrap up the conversation, and it's been great, to put on the hat and say, I'm going to look down the road where this evolves to, the utilization of air-blown fiber technology in MDUs specifically. What do you see in 5 to 10 years down the road?
Well, 5-10 years, I see this being much more accepted technology. The placement of duct in greenfield. So as we build more and more of these MDUs and we place duct in there, I see the use of the smaller ducts, the more air-blown fiber ducts in that space, and by doing so, again, you're going to reduce the amount of material, and there's some safety aspects to that, right? So anything that goes into an MDU has to be flame rated. No matter what you're putting in, if you're putting in bigger material, you're putting in more and more material. That's still material that can burn and cause smoke and is dangerous. If you're putting less material, less likely that you're going to get smoke generation from that. So you have to look at the aspect of, it's flame rated, but I'm putting less of that material in there, so it's even better than the alternate solution. Cost-wise, it's going to be a more cost-effective solution because we're putting less material. So I'm really looking forward to seeing more greenfield applications. It's a very quick and easy installation process as well. We're just inserting duct. So when you look at the technicians that we have out in the field and the need for more and more technicians out there, training is reduced. Placing duct is very simple. I don't have to have a technician that knows how to splice a fiber. I don't need to have a technician that knows how to test. They're simply putting in the duct, and there's a simple method of blowing a small sponge through that duct to verify that pathway is clear. Other than that, we're completing that portion of the construction build, and there's really nothing more that's needed until the customer requests service. That's another aspect of the solution that is I think looked at or not looked at as hard enough, is that we're kind of pushing the fiber installation off to when a customer actually wants the service. So you're deferring the cost of fiber per se, but you're only deploying fiber when revenue is going to be generated, which is key. From the operations side, I really don't want to have a fiber out there that's just sitting there waiting for a customer. I'm going to deploy that fiber when the customer requests service, and I know I'm going to get revenue off of it. So fiber is relatively cheap compared to 2-3 decades ago, but operationally, I don't want to have a fiber out there unless I'm getting service. I don't want to have a fiber that I have to risk a cut or a break or need a repair on unless I have service on it. Another aspect of the air-blown fiber solution is repair. When you look at a duct, repairing a duct is very simple. We have straight connectors that go between the duct. We cut out the bad section, we plug in the new section, and we blow that next fiber in. Because the fibers are so small, they're inexpensive, we can just pull out the old, put in the new, and there's no repair cost necessarily in there. You have to put the drop in, but drops are replaced all the time. When they get cut, you don't see a repair in somebody's yard. You don't see a repair in an MDU. Same thing. We're putting a whole new fiber in, no splices. no worries about failure points. We got the whole system back up and operating as it was installed to start with. So it's very simple, very easy. Again, I don't know of another system out there that is so easy to work with, so easy to install, so quick to deploy. Really, I see this going quite well in the future. Next 5 years, I'm hoping to see, a good portion of MDUs moving towards this solution.
You've touched on a couple of things in that last remark, Roger, that are just so important. The fact that you're, by comparison, only only putting in the fiber that you need,
Yes.
at the point of having a return on that installation, and the ability to replace with great ease. That is something that is a tremendous difference from the traditional approach, and something that really is worth a conversation. And when we talk about that, I know that you and Benny and Brad and the Hexatronic team are more than happy to have a conversation with anyone who would like to learn more about this concept, and so we welcome that. It has been an absolute blast to visit with you today. The more that I learn about this approach to the industry, the more impressed I am, given all the tremendous advantages, and very much appreciate your time today in being able to share your expertise.
Yeah, thank you. I appreciate it. Appreciate
Absolutely.
the time.
Indeed. And on behalf of Roger, thanks for letting us be a part of your day. We'll see you next time right here on the Broadband Universe. So long,
Thank you.
everyone.